In this video, we are going to see an example of first order circuit. Here this question is asking, derive the governing differential equation for the following circuit, express the answer in standard form, and determine the static gain and time constant. First of all, we have to know how does the standard form of governing differential equation should look like. And that should look like this. We have to have a tau and dIL of t divided by dt plus IL of t should be equal to kis of t. Okay, so this is the standard form of governing differential equation. Now we are going to bring this pattern by doing Kirchoff's current law or Kirchoff's voltage law. Here I am going to apply Kirchoff's current law. So I pick up this node, let's call this one V of t, and this is our input, and this side is going to be output. Okay, Kirchhoff's current law says whatever the current entering the node should be equal to current exiting this node. So in our case, current entering the node is Is of t. So Is of Kirchhoff's current law, and Is of t should be equal to current through this resistor and current through this inductor. So current through this resistor is IR of A plus current through the inductor we can call IL of t, and current through the resistor we can use this Ohm's law, and Ohm's law says current is equal to voltage over resistor, so we can represent this one as V of t over RA, and this one we can just leave it like this, IL of t. And also if you take the voltage across the inductor in series with the resistor RB, we can create another equation. Let's call this one equation 1, and if we create the equation using that voltage, this V of t is going to be equal to voltage across this inductor, that's going to be L dIL of t, and then divided by dt, right? dIL of t over dt. I should put small l, right? Because this one for current, dIL of t over dt plus IL of t RB. Okay, this is the voltage through this resistor. Okay, so this is our second equation. Now what we are going to do is we are going to combine these two equations together, because I have this equation, that is, let's say this is equation 2, this is equation 3, this is Is of t is equal to V of t over Ra plus IL of t. Instead of V of t, we are going to plug this value. If you do that, the fourth equation, let's write this one, it's a different color. We are going to have Is of t is equivalent to 1 over Ra, and instead of V of t, I'm going to plug this whole thing. So this is going to become L dIL of t over dt plus IL of t RB, right? Then we are going to have this plus IL of t. So plus IL of t. So instead of writing like this, I can combine this RA together, like I can bring this RA inside. In that way we will have RA in the denominator. So we will have L over RA, and here we have RA, and that's going to be equal, that one plus this equal to Is of t. So we can get rid of this bracket. Now we are going to bring this one into standard form. If you look at the standard form, in the standard form we have to have Is of t other side of equation. We already have that in that pattern, and also this IL of t should be alone. Here we have two IL of t's. We can combine these two together, right? So let's do that one first. So this is going to be Is of t, and here we have L dIL of t, and that one divided by RA dt, and then here we have two IL of t. I'm going to combine these two together. First one is RB over RA IL of t, and the other one is just 1. So 1, I can replace that one with RA over RA. RA over RA is basically 1. I am writing like this because if I write like this, I can combine these two together. Okay, so this is like this, then this one multiply by IL of t, and here we can take RA as a common denominator. It's already the same common denominator, so we can add them together. In that way we will get Is of t is equal to L dIL of t over RA dt, and here we are going to have RB plus RA divided by RA IL of t, Okay, that's it. Now we have to compare this one with the standard form, and if you look at this one, if you in the standard form there's no coefficient in front of this IL of t, so we have to bring the same pattern right here. So in order to bring the same pattern, what we can do is we can divide everything by RB plus RA over RA. In that way I will get rid of this coefficient in front of this IL of t. Okay, and if I do that, this is going to turn into RA over IS of RA over RB plus RA IS of t, and that's going to be equivalent to this RA will be in the denominator. It's okay, we are dividing everything by RA, so we are going to have this RB plus RA. I made a mistake right here. This one I should divide this one by RB plus because I have to divide exactly the same thing, right? So this is going to be RB plus RA over RA, and if I do that, this is going to become IS of t divided by RB plus RA over RA. So this RA will flip around and go to the top, and in the denominator we will have RB plus RA, and that's going to be equivalent to, here this RA will flip around and go to the top, and that's going to cancel with this RA. So we will have this RB plus RA in the denominator, so we will have L DIL of t and RB plus divided by RB plus RA, and this one cancel all together, so we will just get plus IL of t. Now we have derived our standard form. The next step is, the question is asking us to find out the static gain and the time constant. Time constant is the value in front of the dIL of t over dt. In our case, dIL of t over dt, we have in front of dIL of t over, oh, I had to put a dt right here. dt, I have L over RB plus RA. So this one, so the time constant is going to be L over RB plus RA, and the K, that is static gain, that is the value in front of IS of t. In our case, the value in front of IS of t is RA over RB plus RA, right? So this is going to be our K value. K is going to be equivalent to RA over RB plus RA, and that's our final answer. I hope this helps. Thanks for watching.